Hi, I'm Martin from weeteq, and at weeteq we do power and control system optimization, but in a totally unique way. So what we're talking about here is a paradigm shift from system optimization being the domain of cloud, local, and even edge solutions to one where system optimization is taking place at a microcontroller level. So weeteq innovations are applicable to many of the world's largest industries, and these industries are constantly innovating, spending huge amounts of money each year on innovative technologies. But despite this spend, there's still some lingering challenges with each of these industries. So what's the problem? Well, in power electronics, there remains inefficiencies which have just been accepted as inevitable. And we're going to talk about one of those in a moment. But technology's really not been there to solve the problem. And when we do innovate, companies generally take the big data approach without necessarily understanding what's available within the circuits of devices. And then finally, anomaly detection is seen as the goal, seen as a success. This idea that weeteq are bringing to the table of real-time system response correction is simply not on the radar yet. So let's dig into this in a little bit more detail and talk about the solution that weeteq brings to the table. So if we look at the way that things happen at the moment, this is the status quo where we have multiple data sets being gathered from sensor information, from device outputs and generic information about the machine. And this is analyzed, whether that's at the cloud, locally or at the edge, to detect patterns in the data which results in understanding anomalies. And then some instruction is sent back down to the machine. And this is really what's happening at the moment. So with weeteq, what we do is we flip this completely on its head. So instead of deploying more and more sensor and network infrastructure, we're accessing existing operational data, which is available directly within the circuits of devices. And this is what we call ultra edge. So we call it ultra edge as it goes beyond edge computing. We're doing real-time analysis from within the circuit itself, finding operational data at that level and detecting anomalies at an ultra early stage. We can then take that data and then send that back up the chain to enterprise applications as they need it. This is phase one of our solution. Phase two is that we're actually able to change the output from the control loop. So we're able to provide immediate performance improvement of the asset. So this is identifying and correcting inefficiencies, anomalies as they happen. And this is what we call real-time system response correction. So the way in which we deliver the solution, we have a suite of embedded solutions and enterprise applications, from embedded software through to our dynamic digital shadow interface technology, which interfaces the circuit to enterprise applications, and ultimately our silicon IP for large growth. Where we are right now, we are deploying pilot projects, and these are available now. So this is to prove the technology out in our customers' environments. Just to bring it to life a little bit, this is an example of a torque transition. So on the left-hand side, you have without ultra edge, and on the right-hand side with ultra edge. So when we go through a torque transition, which could be a change in load on a conveyor, it could be a press of the accelerator in a electric vehicle, what we have is these peak current overshoots, and we see these whether the motor is optimal or suboptimal. On the right hand side, we have weeteq eliminating these transient peak power overshoots. So really what's happening is we're identifying the anomaly, correcting the anomaly, so that we have a result which is far more aligned to how the designer had built the system in the first place. And we're able to do this because of how quick our implementation is, which is 480 times faster than the current ARM ML implementations. So where this works in industry, in industrial automation, we can provide baseline efficiency improvements, so around 1 or 2%, and significantly reduce machine downtime. We're also able in electric vehicles to extend the range, to make vehicles with smaller batteries, and provide step change improvements in things like energy classification of domestic appliances. So this is the team that's making everything happen. We've got 5 full-time members here in Glasgow. We've got 5 outsourced digital design engineers as well, split between San Diego and Istanbul. And we have a team of advisors, including Sean Redmond from Silicon Catalyst. So I'll leave you with this summary. Please do reach out if you have any further questions. Visit the website. You can scan the QR code there, which gives you more information specifically about the raise. And thank you very much for listening.